Here's a graphic picture of the box above that we just talked about. So the mother function is given as a dotted line. And you can see when you multiply by 2, the parabola gets thinner. When you multiply by 1/2, the parabola is wider. And the same happens when the parabola is cupped downward. The parabola, the mother function is the dotted. You can see by multiplying by 2, even though it has a negative in front, it still makes it steeper, thinner, skinnier, rise more quickly, and the fraction makes it wider. So how do we do this graphically? Well, I think of it as saying, take the y and multiply it by 2. So I like to draw the mother function first, not draw it, but write the table for it, 0, 0, 1, 1, 2, 4, that we wrote down before. And remember, that's just comes from here, because some students think, oh, she just came up with these magical numbers. No, when you put 0 in, you get 0. When you square 1, you get 1. When you square 2, so that's the mother function. Well, when I'm going to be multiplying by 3, y is 3 times larger, because remember f of x is y. So I keep my same x's, but y is going to be 3 times larger, because that's what this says. Y is 3 times larger. So take each of these numbers and multiply them by 3. And that will give you your new t-table. So 0 times 3 still 0. So the parabola will still be placed at the origin, the vertex. 1 times 3, see how it's going up 3 times faster? It was to 1, now it's going up to 3, so it's going up 3 times faster. And then 4 times 3, 12, which we're not going to be able to put on this little graph, so we'll just be able to put the first 2. So over 1, up 1, 2, 3, and then left 1, up 1, 2, 3. And then the other one, like I said, I guess we could guess over 2. So if this is 6, 12 is going to be double that. So maybe 12 would be about right here, because this distance is 6, add 6 more. So I guess we might as well go up there. Over 2, up 12. And then left 2, up to 12. So you can see the parabola is quite thinner than the mother function's parabola, because it's 3 times further. So you have to remember f of x is really y. You learned that back in 092 when you were learning functions or in your high school classes. So y is 3 times larger. That's how I knew to multiply the y's by 3. So now we can draw a parabola. It's going to be a little bit harder to make it round, because now it's so thin, but we can still do it. Just don't make it a point. Yes, it's going to be pointier, but it's not a point. It's still rounded. So there's our thinsy little parabola, because it's been multiplied by 3. So our next one should be thinner, right? Excuse me. Hello. Should be wider, because we're going to multiply y is 1/3 times larger. Well, 1/3 of something makes it smaller. So do the same thing. And I'll do these two, and then I'll let you guys practice on 2. So I like to have my regular t-table here. 0, 0, 1, 1, 2, 4. And this time y is 1/3 times each one. So times 1/3, times 1/3, times 1/3. And it's important that you remember when you're doing your homework on Connect that the x's don't change. We're not changing the x's, we're changing the y's, because we're either stretching it or making it wider. The x's always stay the same. And then 0 times 1/3 is 0. This parabola also cups up because it's positive. 1 times a third is 1/3. And 4 times a third, you can do it on your calculator or in your head, it's 4/3, which is 1 1/3. And if you multiply it on your calculator, 4 times 1 fraction bar 3, it will give you that 1 1/3. So we go over 1, up a third. So see how it's going up more slowly? That's what makes it wider. Over 1 to the left, up a third. Over 2, up 1 1/3, so just barely above 1. Left 2, up 1 1/3, so just barely above 1. So here's our new parabola, a little bit thicker than the home function, mother function. So you have to think of that number in front as just being y is 3 going up 3 times faster. Y is 1/3 times something. And when you take a third of something, that makes it smaller. That's why these numbers are smaller. These numbers are larger. Okay, go ahead and turn over to page 4 and try those two at the top. I think they're both negative if I remember right. So you're going to be doing the same thing, but just going downward. So shut off your video. Try those two. If you're not sure, just put it in a pencil and you can erase if you need to when we go over it. Okay, so the mother function is 0, 0, 1, 1, 2, 4. The new one is going to be each of these multiplied by -4. Because it says y is -4 times larger. Because g of x, f of x, h of x, those are all just y. So x never changes, and y, 0 times anything is 0. 1 times -4 is -4. 4 times -4, -16. So that one whoops, why did I write -4? I said -16, wrote -4. So 0, 0. So this says go over 1, down 1, 2, 3, 4. And then go left 1, down 1, 2, 3, 4. And the 16, that's just too much, so we'll just draw it from there. On tests, we require that there's 5 points on the graph, so obviously we'd either give you a bigger graph or smaller number on the test, because parabolas are supposed to be drawn with 5 points. But these graphs are a little smaller, so we'll have to do with 3. So there's one side of it, arrows on both ends, and there's the other side, arrows on both ends. So a nice little skinny parabola, cup downward because of the negative in front of the 4. So how'd you guys do on that one? Okay, so this one I can tell is going to be a reflection, which means flipped over, and it's going to be wider because I'm taking half of it. Multiplying by 4 quadruples it. Taking half of it cuts it in half, so it makes it go up more slowly. So the mother function, 0 squared is 0, 1 squared is 1, 2 squared is 4. So this one says multiply each number by -1/2. So times -1/2, times -1/2, times -1/2. So our new is going to be 0, 0 still, because wow, I'm having a hard time talking today. 0 times -1/2 is still 0. 1 and 2, remember, stay the same. 1 times -1/2 is -1/2. So see how it's going up more slowly. Half of 4 is 2. A positive times a negative, -2. So we put our 0, 0 in. We know the parabola's cupping downward. We know it's going to be wider from the box on the other page, wider with fractions, steeper, thinner with whole numbers. And over 1, down a half, left 1, down a half, over 2, down 2, over 2, down 2, the other direction. And there is our parabola that has been reflected across the x-axis. That just means it's tipped over. So reflected across the x and wider than the mother function because of the fraction. So tipped over the x-axis, that's called a reflection. And then it is a vertical shrink because of the fraction. So let's label these so that we remember those names. So this is called a vertical stretch because it's going up vertically faster or going down vertically faster. And this is called a vertical shrink because in this case it's going down slower, so it's shrunk vertically. Where this one, think of it as stretching it like a rubber band. This one is going down more slowly. So that's called a vertical stretch, a vertical shrink, and it works both for parabolas cupping up and parabolas cupping down. Okay, let's go over this next box and then we'll practice on the example on the next video. So now we're going to put it all together. We're going to have parabolas that move left, right, up, down, vertical stretch, vertical shrink. So not just one thing is happening to them, many things are happening at once. So probably the most important thing in this whole box is how you identify the vertex. So the vertex is the opposite of what's with the x. So it's h, comma, k. So it's right h units, up k units. Because remember how we always do the opposite, negative means go to the left, but when it's with the x, that means right h units, up k. So when it's with the x, it's left and right movement, but do the opposite. When it's outside, that's up or down. If k is positive, it's shifted up. If k is negative, it's shifted down. And then, of course, A is the vertical stretch or vertical shrink that will occur. So our vertex is the opposite of what's in parentheses, comma, whatever constant is out back. The axis of symmetry, which is this little line here that cuts the parabola into two symmetric halves, is always going to be x equals h. And that's just not something you should memorize. That's something you should know from previous classes. Anytime you have a vertical line, it's always x equal because it only passes through the x-axis. And what does it equal? Well, if it goes through the vertex, x equals h. So these should always match whatever the first coordinate of the vertex is. It should always be x equals whatever that is. And we already know that when the value of a is greater than 0, which means it's positive, it opens up. So let's just write that. A positive, that's the number in front, remember, is the a. That means it opens up. And since it opens upward, does everybody agree that the vertex is going to be the lowest point on the graph? So we call that a minimum at y equals whatever y is in the vertex, k. When a is less than 0, that means a is negative. So when the number in front of the parentheses is negative, then it cups downward. And you can see when it cups downward, the vertex is going to be the highest point on the graph, so we call that a maximum. And that a maximum occurs at y equals k. So k is the up and down, the y coordinate, And isn't that how high or how low something is? It's always your y value. So that's why it's always y equals whatever this is.